Hey, so this is an example from the book. It's a homework problem that I want to work out with you. So in this problem, we're asked to solve the initial value problem. Y prime is equal to t divided by y, where y of 0 is equal to 1. So it's really good to note is that y of 0 equaling 1, that tells you that when t is equal to 0, y is equal to 1. So as we do our approximate solution, that's going to be our first point, our initial value here. So in this problem, part A asks us to find the value for t being 0 0.1, 0 0.2, and 0 0.3, where h is equal to 0 0.1. So h is equal to 0 0.1, and that'll be important for our step. So the first thing I'm going to go ahead and do is think about, well, what step are we? So our n values, first step, second step, third, fourth, etc. Okay, so our t value and our y value. So when we're just beginning before we've actually done anything, we already have t 0 and y is 1. This will be very helpful for us. The other thing that might be helpful to include here, and this is the way I like to do it, although there are multiple ways of writing your table, is I'll also include a column. And in that column, I'm going to put my function value, so my f of t and y. And what this is given by your equation right here. So it's going to be taking whatever your t value is and dividing it by the y value. Great. So with our step size being 0.1, this will be very helpful. So that tells you for each t, we increment by 0.1. So we add 0.1. And you can go ahead and fill in a couple of these since the t's are going to move very smoothly. What then happens is, well, we need to find out our y value. So recall the equation we're using here is we say, well, the one we just used is to advance the t's, we just add the h each time. For the y, it's a little bit more complicated, where it says for the next y value, you think about where you are, and we're going to add to it h times the function, which is really your y prime. So it's, think about how your derivative is given the first time you ran into derivatives as the slope of a tangent. And so here we're thinking the slope, what's the direction we're going in? And we're going to go in that direction. Right? Now, if that's the rise over run, if you multiply by the h, it gives you just the rise. And so this is how we approximate this. So function value there. Great. So to get to my new y value, I will need the f value. So for this first entry for f, with this equation, it's really just t over y divided by y. So this just gives you 0. So for my y value, so my y, we'll call it 1. Maybe I'll use a different color here. Let's put it in green. So my y of 1, that's going to be y of 0. We add to it h times, f of t naught y naught. So this is 1 plus 0.1 times what we just found, 0. So that gives you your new y values, in fact, 1. And then we can go ahead and do the next move where you the function value of 0.1 divided by 1 is just 0.1. And then you rinse and repeat. So if we did it again, if you want your next value of y, you think, well, where am I right now? Let's go ahead and move by quantity that's h times the function value. So 0.1 times 0.1. So that gives you 1.01. So because this right here is 1, this right here is plus 0.01. Good. So 1.01. Great. So now this is where I'm actually going to pull out a calculator since these numbers are getting a little bit more strange. So for my function value here, what do I need to do? I need to do my y value divided by, I'm sorry, my t value divided by my y value. So for this one, it's 0.2 divided by 1.01. So this is a little gross. All right, this is about, let's say, 1.98. I also have the option of saving that in my calculator, which I might do, or just using the fraction as I plug it in throughout. Okay, so our very last step for this one, we're going to say, well, where are we right now? So for my next value, y3, I'm going to say I am currently at 1.01 is my height. I'm going to add to that an h value, 0.1, times this mess that we just found, which I can write, if you want, I could leave it as a fraction so I don't have to worry about these long decimals. And I can stick all of that into my calculator. Or what I would likely do if I'm actually using a calculator here is I might think about what order am I going to plug these in. Well, this value right there is currently in my calculator. So I could multiply what's in my calculator by 0.1. So I'll do that. So what's in my calculator, I multiply that by 0.1, and then add to that 1.01. That way, it's already all saved in my calculator, and it saves me a little bit of work. So that will give me, here, if we look at this, 1.0298, etc. And for this particular problem, for part A, it just asked us to find the value up to t being 0.3, so we've found it. So here is our approximate solutions when your step size is 0.1. If we were to do this again, we would just follow the same method, but our step sizes would now, instead of being 0.1 here, will be 0.05. And I would expect my numbers to get a little bit more gnarly soon. All right, great.